Hey there, explorers. Ranger Brewery here. It's wintertime here in Colorado, so I'm hanging out with y'all in my greenhouse today. Wintertime in Colorado is full of surprises, though. Some days it's a blizzard, and I have to layer up just to stay warm, making me wish I had a thick fur coat like my dog does. Other days it's sunny and warm where I can go hiking in a t-shirt. These changes in my environment force me to adapt and be flexible. What is adaptation, by the way? It's a characteristic of a living thing that helps it survive in its environment. There are three types. The first one is structural adaptations, such as body parts, body coverings, and physical attributes of an organism. The second one is behavioral adaptations. These are learned or instinctual activities and actions that organisms do. The third one is physiological adaptations. These are similar to the structural and behavioral ones, but these are internal changes that animals go through, and they're not always observable in their appearance. They can even help other adaptations work better too. Thinking back to me and my dog though, we can determine that her thick fur coat is a structural adaptation, and me putting on a jacket or going inside to warm up is a behavioral adaptation. We can learn a lot about animals by studying their adaptations. By understanding how animals survive in the wild, we can better appreciate the flexibility of the natural world and some of the amazing animal superpowers that have been selected for over millions of years. Super speed is found in both predators to catch food and prey to escape becoming the food. Predators also have eyes in the front to hunt. This creates a parallax that helps them with depth perception. Prey have eyes on the side so that they can hide. It gives them a wider range of view to look for any danger. The power of flight comes from having wings, like in birds, and only one of the mammals, the bat. Other fun and common physical superpowers include camouflage to blend in and hide from other animals, using fins or webbed feet to swim through water, gills to breathe underwater, or even growing and shedding fur coats to live in dynamic climates. Essentially, nature has evolved many structural adaptations for animals. I want to take a minute though and talk about specific aspects of adaptations. Sensory perception. We owe a lot to our five senses: sight, smell, hearing, taste, and touch, and to the structural organs that help us with those senses. They help us perceive the world around us, but there's a lot that we are actually unaware of because we don't have the structural organs to sense something, or it's simply outside of our range of perception. Many animals have much better senses than us too, or sometimes they even have totally different ones. Some super senses that fall into the structural adaptations category include bears with super smell. They can smell food up to 20 miles or 32 kilometers away. This is one of my favorite fun facts when I educate our campers and hikers about bear safety in our parks and why it's so important to be aware of any food that we have out. What about super sight? We can see in the visible light spectrum, which includes all of the colors of the rainbow and those in between. But visible light waves are only part of a much bigger electromagnetic spectrum. Some animals have adaptations in their eyes allowing them to see ultraviolet light or UV light, like the bumblebees. They co-evolved with flowers. To us, a yellow flower is yellow, but to pollinators like the bees, the UV patterns can actually form a bullseye design that acts like a beacon to draw the bees in. This is also a way that we're currently learning that nocturnal animals can see in the dark, in addition to having different structures that aid in night vision. Super hearing is common in many prey animals. That helps them hear any approaching predators. But even cooler is the use of hearing to see. Echolocation is what bats and dolphins use to find food. They send out a super high-pitched sound, and that wave bounces off a mosquito or a fish and returns as an echo or a picture that tells them how big and how far away their food is. Have you ever used a GPS or a compass to figure out which direction you're going? Many animals are magnetoreceptors, where they have magnetite in their cells that act as a compass to tell them which way they're going. Whether it's a bird migrating to warmer weather, or a female sea turtle finding the same beach she hatched from years prior to lay her eggs. These compass cells are a physiological adaptation that helps an animal in adapting behaviorally to their environment. Other physiological superpowers are examples like frogs producing poison along with their bright coloration to warn predators away, snakes producing venom to accompany their sharp fangs, and even skunks with their stinky smell. There are other ways animals can change their behavior to survive better. Think about how bears, frogs, and even hummingbirds slow down their heart rate and metabolism to survive cold weather. This is called hibernation. But maybe some animals like birds and sea turtles decide they would rather just travel to somewhere warmer. This is called migration. And some animals change their behavior for other reasons too. The animal kingdom has developed some pretty fancy dance moves even to impress potential mates for reproduction. Whatever the adaptations are, the one that works the best to help the species survive longer will get passed down to the next generation to ensure that their offspring is going to be set up for success. So I have a question for you. What animal superpower would you choose to have? In these activities, we're gonna go explore some of the natural open spaces near you and see what kind of animal superpowers are in your area. So let's go.